this video, we are going to attempt a gas laws structured question. So question 1 says that there is a sample containing 40 liter of hydrogen gas and 30 liter of oxygen gas. Identify the limiting reactant and determine the volume of water vapors produced. So first of all, you can see with hydrogen and water there is 2:2. So if this is 2, this is also 2. So if this is going to be 40 liter, the water vapors are also going to be 40 liter. So first of all, we can write 40 liter of water vapors produced. Then we have to find the limiting and excess reactant. So for limiting reactant, we first need to find the moles of hydrogen gas, and as you know, that is available volume of hydrogen gas. So we can find out the moles of hydrogen gas, which is equal to volume of gas divided by 24 liter, which is going to be molar volume, and then that for moles of oxygen is going to be volume of oxygen 30 divided by 24. So we have found the available mole of hydrogen, that is 1.67, and for oxygen is 1.25. From available mole of hydrogen, we are going to find the required moles of oxygen. So for that, we are going to use the table method. 1.67 mole of hydrogen, and they are reacting with, and from the equation you can see 2 mole of hydrogen, that is reacting with 1 mole of oxygen. So required moles of oxygen comes out to be 0.835, but available moles are 1.25. So available mole of O2 are greater than required moles of O2. What that means? That means O2 is in excess. Then who is going to be the limiting? Definitely hydrogen is the limiting reagent. Hydrogen is a limiting reagent. So in this question they are saying calculate the volume of excess gas remaining after the reaction. So if you see that we have 40 liter of H2, and H2 is the limiting reactant. So limiting reactant controls the amount of product. So one thing is that 40 liter of H2, as it is 2:1 between hydrogen and oxygen, so 40 liter of hydrogen requires 20 liter of oxygen, but in fact we have 30 liter in the beginning. So how much is going to be remaining O2? 10 liter of O2 which has been remaining. And how much amount of water has been produced? That is 40 liter. 40 liter of water vapors plus 10 liter of oxygen gas is there, so it becomes 50 liter of gas that has been formed. So total volume of gas is going to be, total volume of gas is 50 liter, in which we have 40 liter of water vapors and we have 10 liter of oxygen gas. Why 10 liter of oxygen gas? We have seen that total gas of oxygen was 30 liter, but as hydrogen is a limiting reactant, so it is reacting with 40 liter. It requires 20 liter of oxygen, but in fact we are entering 30 liter of oxygen. So excess is only 10 liters. So the total amount is going to be 50 liter of gas. So in this question they are saying a flexible balloon contains a fixed amount of gas with a volume 2.0 liter. We can keep it V1 at a temperature of 27 degrees Celsius. We can keep it T1, which is equal to 273 plus 27, that becomes 300 Kelvin. And then we have V2. We need to find out the V2 when it is heated to 127 degrees Celsius. So converting T2, that is 127 plus 273, that comes out to be 400 Kelvin. This is a formula. V1 T1 is equal to V2 T2, and we have to find out V2. So this one would become V1 T1 divided by T2. V1 here is going to be 2 liter times with T1, that is 300 Kelvin, divided by T2, that is 400 Kelvin, and the answer comes out to be 2.67 liter. So they are saying explain why the volume of gas increases when the temperature increase at the constant pressure. So what happens because of high temperature? A high temperature increase the kinetic energy of the particles, and because of that what happens, kinetic energy is directly proportional to temperature, and what happens because of that, there would be more frequent collision with the walls, and because of that they are pushing them outwards outwards to maintain constant pressure. Okay, so in this question they are saying that we have two compounds CS2 having boiling point of 319 Kelvin and COS having boiling point of 223 Kelvin. So we have two different compounds, and we can see one thing here, that they are saying in terms of type and relative strength of all intermolecular forces in each compound, explain why the boiling point of CS2 is higher than that of COS. CS2 has only London dispersion forces. This one is having only London dispersion forces, while this one is going to have two forces. The one is London dispersion force, and the second is going to be dipole force. So how do we know that CS2 is going to have only London dispersion forces? So first of all, if you see the structure of CS2, you are going to see that this molecule is linear, and if it is linear, it is going to be non-polar because same atoms are on both sides. So what happens, that the dipole, they cancel out due to symmetry. Okay, so they are non-polars, and dipole cancel out because of symmetrical molecule, and symmetrical molecule is this one. So dipoles cancel out each other, and they are going to have only London dispersion forces. While if you see COS molecule, then you are going to see in COS molecule that in COS molecule it is going to have carbon oxygen bond and carbon sulfur bond. Then what happens in them, that they are going to have, like, this is going to be, oxygen is more electronegative, which makes one side to be like having the uneven distribution of electron density, uneven distribution of electron density, and because of that it is going to have two forces. The one is London dispersion force and the other one is dipole force. So CS2 has stronger London dispersion forces. CS2 has stronger London dispersion force. That is why it has high melting point, boiling point as compared to COS, which has combination of both forces. So they are saying a 10-gram sample of CS2. So first we are going to find the mole of CS2, that is mass over molar mass of CS2 is 76.13, that comes out to be 0.131. And then they are saying we have to use the formula P is equal to nRT divided by V to find the pressure. Moles are 0.131 mole. R, the value of R is going to be 0.08206, and that is in liter atm per mole per Kelvin. And then temperature here is going to be 325 Kelvin. And at bottom we are going to put the volume, which is going to be 5 liter. So pressure, that comes out to be 0.70 atm. So next question says a student is doing experiments with CO2. Originally a sample of the gas is in rigid container at 299 Kelvin and 0.7 atm. The student increased the temperature of CO2 in container to 425 Kelvin. Describe the effect of raising the temperature. The average speed of the molecule, the average speed of the molecule increase by increase in temperature. Okay, because kinetic energy is directly proportional to temperature. So next question says that calculate the pressure of CO2 gas in the container at 425 Kelvin. So first of all, we are given here with different things. The formula for that one is going to be P1 divided by T1 is equal to P2 divided by T2. P1 here is going to be 0.7 atm, T1 is 299 Kelvin, and T2 here is going to be 425. Putting them in the equation, we are going to find P2. So P2 formula becomes P1 T2 over T1. P1 is going to be 0.7 divided by T1 is going to be 299 and we are going to times by 425, and the answer that comes out to be 0.99 atm. So next question says, in terms of kinetic molecular theory, briefly explain why the pressure of carbon dioxide in the container changes as it is heated to 425 Kelvin. So first of all, remember the pressure of a gas is dependent on the collision of particles with themselves, and secondly with the wall of container, and with the wall of container. So what happens there? Faster moving gas particles collide more frequently with the wall of container, thus increasing pressure. So next question says that student measures the actual pressure of CO2 gas in the container at 425 Kelvin and observe that it is less than the pressure predicted by ideal gas laws. So first of all, according to ideal gas law, that one thing is going to be clear, that particles do not interact with each other. Particles do not interact with each other, and there is no intermolecular force. So when they are not interacting with each other, that means they have low pressure. So that means, like, the attractive force, we can write here the attractive force between CO2 molecule results in a pressure that is lower than the pressure predicted predicted by gas laws. So in this question they are saying carbon tetrachloride can be synthesized according to the reaction represented, and they have given us temperature is in 120 degrees Celsius, and we have to convert it into Kelvin. 120 plus 273, and that comes out to be 393 Kelvin. And then we have to find out first the number of moles. Mole is equal to N is equal to PV by RT. Pressure is going to be 0.4 atm, and volume is going to be 25 liter. Value of R is going to be 0.08206 times with the temperature, that is 393 Kelvin, and number of moles that comes out to be 0.31 mole of Cl2. So in the next part they are saying how many grams of carbon disulfide are needed to react completely with chlorine in gaseous form. So you can see one thing, we have to put CS2 on right hand side because we need to find its moles, and Cl2 we can put on the left hand side. From the equation is going to be 3:1, and if we are given with 0.31 mole, that is going to be X, and X comes out to be 0.103. They are the mole of CS2. And for mass, what we need to do, mole time molar mass, moles 0.103 times with the molar mass. Here it is going to be 76.13 gram, and the answer comes out to be 7.9 gram of CS2. At 30 degrees Celsius, the reaction is thermodynamically favorable, but no reaction is observed to occur. However, at 120 degrees Celsius, the reaction occurs at observable rate. Explain how the high temperature affects the collision between the reactant molecule so that the reaction occurs at observable rate. So, in order to answer this question, what happens at high temperature? At high temperature, we can write here, at high temperature, what happens? The particles have greater kinetic energy than at lower temperature and then what we can say, thus there are more collision with sufficient energy. Thus there are more collisions with sufficient energy to overcome the activation energy. And now they are saying to draw a graph that shows the distribution of collision energy with reactant molecule at 30 degrees Celsius. So temperature before was 120, and this graph represents 120. And remember here they are showing it for 30 degree. We need to show it for 30 degrees. So remember one thing, when we are going to show for 30 degree, graph will go towards left hand side. That will go towards left hand side, and it is going to be at this point. So this is the place for 30 degrees Celsius. When the temperature decrease, graph move towards left side, and when there is increase in temperature, it goes to right hand side. S2Cl2 is a product of a reaction in the diagram below. Complete the Lewis electron dot diagram for S2Cl2. So first of all, valence electron for sulfur is how much? That is 6 times 2, because there are 2 sulfur, and valence electron for chlorine is 7 times 2, and that is going to become out 12 plus 14, and that is going to be 26. So first draw the bonding electrons. One pair of electron, I have drawn it, and then we have to show the remaining lone pairs. These are the lone pairs. Yeah. So how many electron it becomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So it has been completed. Now for the Lewis diagram, we need to remove them. Instead we need to draw a straight line like this. So they are saying we have to find out the angle at this point. So if we want to find out the angle, so first of all it is sp3 hybridization. How I know? This is S, this is sp, sp2 and sp3 hybridization. As for sp3 hybridization, the angle is 109.5, but as there are two lone pairs present there and here, so it has been reduced by 2 times 2.5 and answer comes out to be 104.5. So they are saying identify all type of intermolecular force present in HCl. So if you see HCl, HCl is a polar molecule which contains dipoles, because chlorine is more electronegative, so it is going to have partial negative, partial positive. So one force that is present here is going to be dipole force. It has dipole force, and the second force of attraction is going to be London dispersion force. That is going to be present there. So in this question they are saying what can be inferred from the relative strength of intermolecular force in CCl4 and HCl. They are saying that its CCl separates the CCl4 gaseous state from the HCl by cooling the mixture to 70 degrees Celsius. So CCl4 converts to liquid at 70 degrees Celsius, but HCl remains in gas phase. What we mean by that? That means in CCl4 the force of attraction is much stronger. The force of attraction in CCl4 is much stronger force, that it is going to be converted into liquid state even at 70 degrees Celsius, while HCl remain in gas phase. Okay, so what we can write here, the intermolecular force in CCl4 molecule must be stronger than those among HCl molecule, because CCl4 condenses at high temperature than HCl. Question they are saying ethene, which has a molar mass of 28.1, may be prepared by dehydration of ethanol. So this is ethanol, and a dehydration means removal of water. So removal of water has been done from ethanol and it is going to form ethene and water vapors. A setup for the lab synthesis is shown below. A student adds 0.2 gram sample of ethanol to a test tube using the setup shown above. So they have added ethanol here, and from ethanol they have heated ethanol, and what is going to happen, ethene has been collected here along with water vapor. So they are saying When the reaction stops, the volume of collected gas contains two gases, one is this one is this one, and their total pressure is 0.822 atm, while the pressure of water is going to be 35.7 torr. So first let's convert 35.7 torr into atm. So 35.7 torr, that is going to be what we need to do. 1 atm contains 760 torr. So that is going to be 0.0470 atm. Total pressure here is going to be 0.822 atm. Okay, and now in the first question, what they want us to find out, they want us to find out the number of moles, calculate the number of moles of C2H4 first of all, and then what we need to find out the further. First let's see, find out, first find out the moles of ethanol, and for that purpose we need to use the formula N is equal to PV over RT. Okay, we have to find out the moles of ethene. This is ethene we need to find out. But for ethene we need to know the pressure, and total pressure, if you see, the total pressure is going to be 0.822 atm, and the pressure of water is going to be how much? That is 0.0470 atm. We have converted this torr into atm here. So pressure, total pressure is equal to pressure of ethene C2H4 plus pressure of water vapors. So if we want to find out the pressure of ethene, we have to subtract total pressure minus water vapors, pressure of water vapors. So total pressure is going to be how much? 0.822 minus, that is going to be how much? 0.0470, and the answer that comes out to be is 0.775 atm. Then after that we have to find out the moles of ethene. Pressure is going to be 0.775 times with the volume, and volume here is going to be given, that is 0.0854 liter divided by R, 0.08206 times with the temperature, that is 305 Kelvin, and the moles that comes out to be is 0.00264 mole. So in the next question they are saying that we have to, the number of moles of C2H4 we have to find out. So we have just find out the moles of C2H4, and then yes, for the next part, calculate the number of moles of C2H4 that would be produced if the dehydration reaction went to completion. For that purpose we are given with the mass of C2H5OH, that is 0.2 grams, and we first need to find the moles of C2H5OH, that is mass divided by molar mass, that is going to be 46.1, and that comes out to be how much? 0.00434 moles. And C2H5OH and C2H4 is going to be 1:1. So if this is 0.0043, that is also 0.0043. So 0.0043, they are the moles of they are also the moles of C2H4. First moles are 0.00264. And now percentage yield we have to calculate. So percentage yield, the formula for percentage yield is going to be actual yield. So this is actual yield. This is actual yield, and this is going to be theoretical yield. Theoretical yield. Theoretical yield is the yield. Actual yield is actually given, and theoretical yield that you find from equation. So by putting in the formula percentage yield, that is equal to actual yield divided by theoretical yield times it with 100. So actual yield is going to be 0.00264 divided by theoretical yield, that comes out to be 0.00434, and times by 100. So it comes out to be 60.8%. So in this question they are saying draw the dot and cross diagram for this ethanol. So carbon has 4 valence electron, and 2 carbons are going to have 8 electrons, while hydrogen has 1 2 3 4 5 6. 6 hydrogen has 6 valence electrons, and then we have 1 oxygen which is going to have 6 electrons. So total becomes 20 electrons. So first draw the bonding pairs there. And then we can just, this is going to be the Lewis diagram for this one. And in part E they are saying that the approximate angle of COH. So in order to find that, the bond angle for COH is going to be, so oxygen in the center, we have to find this one. Oxygen in the center is going to be like sp3 hybridized. For sp3 it's going to be 109.5, but there are 2 lone pairs that are attached, so it is going to be 109.5 minus 2 times 2.5, so that comes out to be 104.5. so 104.5 is going to be its bond angle. During the hydration experiment, an unreacted C2H5OH is passed through tube in the water. The C2H4 was quantitatively collected as a gas, but the unreacted C2H5OH was not. Explain this observation in terms of intermolecular force between water and each of the two gases. So first of all, that ethene is a non-polar molecule. And only slightly soluble in water, while ethanol is polar, while ethanol is polar and highly soluble due to difference in polarity, due to difference in polarity. Then ethene molecule interacts with water molecule, interacts with water molecule through weaker induced dipole force, whereas ethanol molecule dissolves in water due to hydrogen bonding,